Assalamualaikum warahmatullahi wabarakatuh. My name is Nuliana Balkis binti Hairi. Metric number AE190058. I will present about activity 1. Okay, this activity, we need to construct this circuit by using software, and choose multi-sim software. Okay, the AC supply, the value is 14.6 volt. The frequency is 50 Hz, and the resistor one is 100 ohm, and for the variable resistor is 1 kilo ohm. Okay, let's try simulate the circuit. Okay, first of all, we need AC voltage. Okay, and we set the value is for the voltage peak we set 14.6 volt, and the frequency we set into 50 Hz. Okay, next we need a resistor. We need 100 ohm of resistor. Okay, the next component is variable resistor. We need 1 kilo ohm. Okay, next we need a ground. Okay, let's try connect. Okay, and make sure this set into 100%. Okay, we need oscilloscope. Okay, this is the oscilloscope for voltage supply. This is the oscilloscope for resistor 1. And this is the oscilloscope for variable resistor. Okay, let's try run and check the result. Okay, this is the graph for the voltage supply. Okay, let's check the amplitude. Okay, the voltage peak is 14.543. Okay, let's check for resistor 1. Okay, we adjust the scale. Okay, and let's try check the amplitude. Okay, the amplitude for resistor 1 is 1.322 volt. Okay. Okay, let's try check the amplitude for variable resistor. Okay, the value is 13.221 volt. Okay, this is from the simulation. Okay, this is the graph that I have drawn. Okay, for voltage AC supply, this is the graph, and V peak to peak we get 29.2 volt, and VRMS we get 10.3 volt. Okay, the period is 20 millisecond, and the frequency we get 50 Hz. Okay, this is the graph for voltage variable resistor. Okay, the V peak to peak we get 26.4 volt. The VRMS we get 9.33 volt. The period is 20 millisecond, and the frequency is 50 Hz. Okay, the next graph is for resistor 1. Okay, the value peak to peak we get 2.6 volt. The VRMS we get 0.92 volt. The period is 20 millisecond, and the frequency is 50 Hz. Okay, that's it from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazmi Shah bin Isa. Okay, I'm going to present to you about activity 2. Okay, the procedure is adjust VR1 to 200 ohms and stimulate and records the voltage across VR1 and R1 by using oscilloscope. So we are using the same circuit as the activity 1. Okay, so this is the simulation circuit that I create. Okay, we only measure for the resistor and the variable resistor only. Okay, to get 200 ohm, we're gonna set it to 20% of 1 kilo ohm for the variable resistor. Okay, then we run it. Okay, we're gonna see the graph at the variable resistor first. Okay, as you can see, the amplitude of the graph is 9.696 and the period is only 20 milliseconds. Okay, next we're gonna see at the resistor. Okay, at the graph we can see that the amplitude is 4.848. Okay, and the period is also 20 milliseconds. Okay, for the drawing. Okay, okay. This the graph that I draw. Maybe it's not accurate because of this handwriting graph, and I run off the data. Okay, okay. First, we're gonna see the graph VR1. Okay, the value of V peak to peak is 19.339 volts, and the value of VRMS is 6.86 volt, and period is also the same, is 20 millisecond, and frequency is 50 hertz. Next, we're gonna see the graph of VR1. Okay, the voltage peak to peak is 9.7 volt and VRS is 3.43 volts. Okay, period is still the same and frequency is also the same. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurshahani binti Abdul Halim, AE 190045. Today I will present you about the equation in experiment 9. Okay, using the equation P equal to VI cos theta, we have record and calculate that the value is V equal to 14.6 volt, I which is current 48.67 milliampere, and the theta is 0. Okay, so we use the formula P equal to VI cos theta, and we get the answer 0.711 volt. Okay, for the second question, using the equation P equal to V square over R. Okay, because we have to record the power distributed by resistor R1. The value for voltage is 4.811 volt and R1 is 100 ohm. And the value we got is 0.231 watt for power dissipated. Okay, for the third question, using the equation P equal to I square R, the calculation we do is P equal to I square R, which is the current is 48.7 milliampere and R1 equal to 100 ohm, and the answer is 0.237 watt. And therefore, do all of the power values agree? No, because the power values is different with the calculate that we have. Okay, that's all from me. Thank you.